Okay, so let's first have a look what we were discussing yesterday and then we will move forward. So we have started our discussion of bit manipulation. Today we will continue with the same set of discussions, correct? And then I have left you with a problem where you were supposed to be decrementing value of any element from the array to make whole jar as 0. I hope you all have tried. If not, then maybe in some doubt session we will look at that problem also. Today we will just continue, we will move a little bit forward, but then before that, till now we have discussed about this jar operator, and then we have concluded couple of interesting things like jar of same number is 0, 0 jar with any number is the same number, and then in jar order does not really matter. So this n1 jar n2 it will be same as n2 jar n1 and so on so forth, correct? Then we took a problem that you were given an array, and let's say this is the array that we are talking about, and then you will be given a value n. Let's say n value is 5, and it said that this is a 1 to n array, but then there is one missing number in this range. Find that number. So we have solved this problem using jar. So what we did, we first jarred every number from 1 to n, and then we appended every element in the same sequence like this, and then we got our missing number. Why? Because repetitive numbers will cancel each other out and we will be left with the number that was missing in our array. Then we also looked at things like the same problem can be asked in different ways. For example, if someone comes to you and tell you that there is a array, and in this array every number is repeated except any one, or they can also tell you the same thing like this: every number is present even number of times except any one number present odd number of times. So for example, this array, okay, or this array also, 3 is present one time, 1 is an odd number. So again the same story, we will just perform jar of every element, so repetitive numbers will cancel each other out and we will be left with the number that is occurring odd number of times. Now see, there is a very beautiful version of the same problem. It goes like this: that you are given an array. In this array every number is repeating. Okay, so this array it might look like this: every number is repeating except any two number. Okay, so for example, look at this particular array. So in this array, except 5 and 12, every number is repeating twice. And then again words can be changed like this, that every number is repeating even a number of times except any two numbers being repeated odd number of times. Okay, so find that, find both of the number. And then you see, the solution to this problem is very easy. What we can do is we can create a hash map, a frequency counter, like so. Initially this map will be empty, so I will go to the first element and then I will check, is 2 present? No. So I will insert an entry like this. Then here, is 7 present? No. So I will insert an entry like this. So key, and then we have value. I have already told you and we have already discussed a little bit about hash map and methods on hash map. Contains key will tell you if a key is present or not. Put method will put a key value pair. Get method will get the value of a particular key, and so on so forth. So again here 3 it's not present, so we will insert something like this. 7 it is present, so we will just increase its value. Okay, 3 it is present, so we will just increase its value. 5 it is not present, so insert an entry like this. 2 it is present, so increase the value. 12 it is not present, so insert an entry like this, and then same goes with 6. So first 6 1, and then because of another 6 it will be 2. So we can do something like this, and then we will run a loop on this hash map, and for whatsoever key my value is 1, those key are my answer. Okay, so here you will find a key 5 with a value 1, then another key 12 with a value 1, so you can get your unique numbers. But you see what people will do, they will tell you that try not to use extra space. Here you have used extra space, your space complexity is order of n, because you are managing a hash map, and this hash map is always going to be in order of n itself. So like there are n by 2 unique elements, So it is going to consume n by 2 spaces, sorry, it will be having n by 2 keys. So you can say that, sir, it is not n, it is half than n, but then from nature perspective it is still order of n itself. Okay, so in order to make this problem interesting, what people will do, they will put these two constraints on the problem. Okay, first your array might go as big as this, things like this, that your array might be as big as this, so that you cannot run two nested loop. Okay, so one another way of solving it is brute force. I will pick 2 and then I will run a loop on whole array and I will check that is 2 present. If it is present, then 2 is not my answer. Then I will pick 7, I will run a loop on whole array from next index. I will check if 7 is present, then 7 is also not answer. So same way, you see, when I pick 5 and I run a loop in this range, I will get to see that 5 is not present. So we can say that 5 is one of my answer. So because of this constraint, you will not be able to do it because it will produce time limit exceeded error. Okay, and then they will put another constraint like this, that please use order of 1 space complexity. Okay, in this case there is another solution for this problem using JOR that we will discuss now. Okay, see, think about it. If they, in our previous problem where we had things like this, that every number is repeating except any one, we just performed JOR of every element and then we got that number that is not being repeated. So here we had one variable, one equation will do perfectly fine. In this case we have two variables, so I will be needing two equations to solve it, and it's logical also. Like if I come to you and tell you that x plus y equals to 10, so there does not exist a unique solution for this particular equation. You might come to me and tell me that, sir, if x is 1, y needs to be 9. If x is 2, y will be 8. So there can be infinite number of solutions. But if I give you one more equation like this, x minus y equals to 20, now it can be solved uniquely. Okay, so what you can do, you can just sum these two equations and you will be end up with 2x equals to 30, so x equals to 15, and then you will put x value in any of the equation, you will find out the y. So we will try to do something like this, not something like this, but then similar approach. Let's say that my first unique number is x and second unique number is y. One equation is very simple. What I can do, I can say that x JOR y is nothing but JOR of whole array. Think about it. Can I say it like this or not? If I perform JOR of whole array, this is what I will get. 2 JOR, 7 JOR, 3 JOR 7, then again 3, 5, 2, 12, 6, 6. So this 6 will nullify this 6, this 2 will nullify this 2, this 7 will nullify this 7, this 3 will nullify this 3, and I will be left with 5 JOR 12. Okay, in this case this is the value. So 5 is this, 12 is 8 plus 4, so this. Okay, so 1 JOR 0, 1, 0 JOR 0, 0, 0, 1. So what is this value? 0, 1, 2, 3, 9. Okay, so one very a straightforward equation that I can figure out is by doing JOR of whole array, and that is nothing but JOR of my unique number. Do you understand this or not, every one of you? Please respond, keep on responding. Is this understood to everyone, that if my first
Yes, sir.
unique number is x and my second unique number is y, so one equation is pretty much forward. X JOR y is nothing but JOR of whole number. Correct? Anyone, any concern till now? No concern. Okay. Now, this equation alone is not sufficient to solve the problem. And reason is very obvious. If we have two variables, I need at least two equations to solve it. Correct? So from where my second equation will come? Please pay close attention. See, think about it. In this case, my x was 5 and my y was 12. It can be anything. Okay, it's just I have picked this particular array, that's why I am analyzing on this. It can be anything, accordingly everything will follow up. And my y was 12, so this is my y. Now this is what I got in my output, x or y. So this is my x, this is my y, and this is my x or y. Do you understand this or not, that it is guaranteed that this value can never be 0. It is never going to be 0. The reason being, in JOR we get 0 only when we perform JOR of same number. This is the only case when you will get 0. And in the problem statement itself they have said that there are at least 2 unique number in this particular array. Okay, so it is guaranteed that x and y are never going to be same. So if that is the case, then this is also guaranteed that your x or y will never be 0. Do you understand this?
Yes, sir.
Okay, now
Yes,
think
sir.
about it. If it can never be 0, then can I say this or not, that this number that you see here, it will have at least one set bit. 0 is a number in which every 32 bit is 0. So I am talking about integers. Okay, so in integers we have 32 bit. So 0 is the only number for which every 32 bit is 0. Any number apart from 0 will have at least one set bit. So if this number can never be 0, then it can also be said like this, that this binary sequence that you see here, it will have at least one set bit. You pick any set bit. And also please remember, this number is 5 now, so 5 is not 0 1 0 1. 5 is first 28 0 and then this. Then again 12 is not 1 1 0 0. 12 is first 28 0 then this. So output that you will get, it's not actually 1001, but then it is 28 0 and then 1001. We are skipping 0 part because it is of no significance. Okay, so we are just analyzing this. Now from this output you pick any set bit. For example, let's say that I pick this. There can be there is going to be at least one set bit. There can be more than one set bit also. You pick any set bit. Let's say that I have picked 4th bit. Okay, so this is my first bit, this is my second bit. I am counting from left because when we talk about bit manipulation, bit positions are counted from right, not left. This is right, correct, and then this is left. मतलब समझ जाओ, we are counting from this direction. So this is my first bit, second bit, third bit, fourth bit. Okay, now think about it. At position 4 we have 1. It simply means that in x and in y at position 4 we should have different bit. अगर सेम बिट होता तो यहाँ हमको 0 मिलता. जैसे कि देखो सेकेंड पोजीशन पे बिट दोनों में 0 है, इसलिए आपके पास आउटपुट में भी 0 है. थर्ड पोजीशन पे बिट दोनों में 1 है, इसलिए आपके पास आउटपुट में 0 है. फर्स्ट पोजीशन में बिट डिफरेंट है, इसीलिए फर्स्ट पोजीशन आंसर में आई मीन जॉर में मेरा फर्स्ट पोजीशन 1 था. फोर्थ पोजीशन पे भी बिट डिफरेंट है, इसीलिए आउटपुट में 1 है. सो कैन आई से इट लाइक दिस कि फोर्थ पोजीशन पे हमारे पास 1 है इन x जॉर y. अगर फोर्थ पोजीशन पे हमारे पास बिट की वैल्यू 1 है, इट सिंपली मीन्स कि x और y में फोर्थ पोजीशन पे डिफरेंट बिट्स है. कैन आई से इट लाइक दिस और नॉट? x में 0 होगा तो y में 1 होगा, y में 0 होगा तो x में 1 होगा. किस में क्या है हमको वो पता नहीं, लेकिन इतना पता है कि अलग है. समझ गए बात को?
यस सर.
करेक्ट. अब आप इस काम को आप किसी भी बिट के साथ कर सकते हो. जैसे कि हमारे पास फर्स्ट पोजीशन पे भी 1 है आउटपुट में, सो इट सिंपली मीन्स कि x जॉर y में अगर पोजीशन 1 पे हमारे पास 1 है, इट सिंपली मीन्स कि x और y में फर्स्ट बिट अलग अलग था, तभी हमारे पास यहाँ पे 1 आया. हमको ये पता नहीं कि x में 0 है या 1, लेकिन ये पता है कि अगर x में 0 है तो y में 1 है, अगर x में 1 है तो y में 0 है। दिस इज द लिस्ट आई कैन से। आप कोई भी सेट बिट पकड़ सकते हो, अभी के लिए आप फोर्थ पकड़ लो and see what I will do after this. Once I have identified a position where bits are different in x and y, अब मैं इस एरे को दो भाग में बांट दूंगा। ओके, सी, एक पार्ट ऐसा रखेंगे जिसमें हमारे पास वो सारे नंबर है जिनका फोर्थ बिट 1 है, एक पार्ट ऐसा रखेंगे जिसमें हमारे पास वो सारे नंबर है जिसमें फोर्थ बिट 0 है। अगर ऐसा करेंगे तो हम, आपको ये बात समझ में आ रही है कि नहीं कि x और y अलग अलग पार्ट में जाएगा। अगर x पहले पार्ट में आया तो y दूसरे में जाएगा, y पहले में आया तो x दूसरे में जाएगा। मैं एक बार फिर से सब कुछ रिपीट करता हूँ। फर्स्ट वी हैव परफॉर्म्ड जॉर ऑफ होल एरे एलिमेंट। Okay, so we have assumed that my first unique number is x and my second unique number is y. When I have performed JOR of whole array elements, repetitive elements will cancel each other out. So you see, this 7 will cancel this 7, this 3 will cancel this 3, this 6 will cancel this 6, and I will be left with a JOR of my unique number itself. Correct? That happens to be 9 in this case. Then I took this 9, and from this 9 I picked any set bit position. Okay, any set bit position. So I have picked the fourth bit position, and then I have divided this array into two parts. One part in which one part will have every element for which fourth bit is 1, another part will have every element for which fourth bit is 0. Why I am doing it like this? Because if we do it like this, it is guaranteed that x and y will fall in different part. Let's quickly have a look. So this is 2, this is 7, this is 3, this is 7, this is 3, this is 5, this is 2, 12 is 8 plus 4, 6 is 4 plus 2. Okay, now 2, fourth bit is 0. I told you 2 is not 1 0, 2 is first 30 0. Everything is in 32 bit. So it is first 30 0, then 1 0. Fourth bit is clearly 0. So 2 will come here. Again 7, fourth bit is 0. So 7 will come here. Again 3, fourth bit is 0. So 3 will come here. 7 will come here. 3 will come here. 5, actually this is a very bad example. 5 will also come here. Okay, then 2 again it will come here. 12, fourth bit is 1. Okay, so 1 2 3 4, so 12 will come here. 6, fourth bit is 0, so 6 will come here. Then again 6 will come here, and let's say that there are couple of more numbers in this particular array. For example, let's say that I have something like this. What is this number? 8, 12, 14, 15. Let's say that I have 15 two times. Okay, so for 15 my fourth bit is 1. Okay, so 15 will come here. Okay, so you see, if I do it like this, x and y will fall in different part. This is my x, this is my y. Now if I perform JOR of first part, repetitive number will cancel each other out and I will be left with 12. If I perform JOR of second part, again repetitive number will cancel each other out and then I will be left with 5. So I can get my both of unique number by performing JOR of first and second part. Do you understand this? Or do you want me to execute it on another test case? Please feel free to ask. Guys.
Got it, sir.
Okay, so I will do one thing. Let's execute it on another test case. We will choose. It's okay, Chandrika. Like from understanding perspective, we will just do it one more time because there are some sub problems also that we need to solve. This time we will be discussing those sub problems also. Let's say this is the array. Okay, so first we have 3, then let's say we have 15, 22. then 23, 23, 22, 7, 9, 9, 2, 2, 28, 28, something like this. Let's say this is the array. Okay, now clearly if you pay attention to this array, you will realize that every number is repeating except this 15 and what? Have I made a mistake? So 3 is also not being repeated.
7.
So here let's put 3 one more time, and now 15 and 7, these two numbers are not being repeated. Okay, so let's say that my first unique number is x, second unique number is y. I do not know what these numbers are. Looking at this array, you can say that 15 and 7, x is 15, y is 7, or x is 7, y is 15. Don't think it like this. Look from general perspective. If I change the answer, x and y will change, but my process will remain same. Let's say that my first unique number is x and second unique number is y, correct? So I need one, so I can say that this is a equation that you can get very easily. X jor y is nothing but jor of whole array. When I perform jor of whole array, every repetitive element will cancel each other. So this 3 will take this 3. Okay, let's quickly confirm if our data set is correct or not. So here this 3 will cancel this 3, this 22 will cancel this 22, this 23 will cancel this 23, this 9 will take this 9, this 2 will take this 2, this 28 will take this 28, and we will be left with 7 and 15 only. So actually when you perform jor of whole array element, now you will get some integer output, and that integer output in this case is going to be this. So here 0, 1, 2, 3, 8, 12, 14, and then 7. This is 7. So 0, 0, 0, 1, 0, 1, 2, 3, 8. So you will get 8. Okay, you will get 8. You will get this integer value. We are analyzing it in binary form because it is easier for us to understand. And from explanation perspective, we will have to analyze it in its binary form only. Now, think about it. If my x and y are unique, then it is guaranteed that this number can never be 0. It is never going to be 0. So if it is not 0, then in its binary sequence, it will have at least one set bit. So if it will have at least one set bit, it is always in your favor to choose first set bit position. Why? You cannot implement it like, okay, I will choose second set bit, I will choose third set bit. You cannot do that. The reason being, it might happen कि उसमें एक ही set bit है, और अगर that is the case in this scenario, अगर आपका implementation जैसे कि अभी थोड़ी देर पहले हमने ऐसे किया था ना, we have picked fourth bit because I know that fourth bit is also set bit. So I have picked fourth. When I say set bit, I simply means bit that is 1. Okay, so I have picked fourth bit. Why? Because we had choice, but we cannot implement it कि fourth set bit choose करेंगे और like second set bit choose करेंगे. ऐसे नहीं कर सकते. क्या होता अगर इसमें एक ही set bit होता, ये 0 होता, second set bit है ही नहीं. Okay, that is the case here. So हम जब implement करेंगे, so from this output we will pick first set bit position. Now in this case, that bit is present at position number 4. So if at position 4 my bit is 1, it simply means कि x और y में fourth position पे bit की value अलग अलग है. तो हम दो सेगमेंट बनाएंगे. एक सेगमेंट हम वैसा बनाएंगे जिसमें वो सारे नंबर रखेंगे जिसमें फोर्थ बिट की वैल्यू 1 है. दूसरा सेगमेंट हम वैसा बनाएंगे जिसमें वो सारे नंबर रखेंगे जिसमें फोर्थ बिट की वैल्यू 0 है. ऐसा करने से क्या होगा, x और y अलग अलग सेगमेंट में आएंगे. देखो ना, x में फोर्थ बिट 1 है तो x इधर आएगा, y में फोर्थ बिट 0 है तो y इधर आएगा. लेट्स क्विकली डू इट. So again, let's write all of these numbers. So this is 3, this is 15, 22 is nothing but 18 plus 4. Okay, and again 18 is 16 plus 2. So 16, 8, 4, 2. This is 22. 0, 1, 2, 3, 4. Okay. Then 23 is, इसको थोड़ा सा और ऊपर करते हैं. 23 is 10111. 10111. Again 22 is 10110. 7. This is 7. 9. This is 9. 2. 28. 28 is 26 plus 2. Again 26 is 18 plus 8. 16 plus 2. कैसे लिखेंगे यार 28 को? रुक जाओ, लिखते हैं. 22 will be divided into 4 plus 18. Sorry, 26. So 4 plus. Can someone tell me binary of 28? 14, 0, 7, 0, 3, 1, 1. So it is 1100, something like this. 0, 1, 2, 3. Tell me binary form of 28 quickly.
11100.
11100. हाँ वैसा ही कुछ होगा. आजकल हम अपना दिमाग कम चला रहे हैं. 11100. 0, 1, 2, 3, 4, 16, 0, 1, 2, 3, 8, 20. 28. Okay, so this is 28. 11100, and then this is 3. Correct. So let's quickly divide it. Fourth bit 3 का 0 है, 15 का 1 है, 22 का 1, 2, 3, 4 0 है, 23 का 1, 2, 3, 4 0 है, 23, 22, 7, 9 का 1 है, 9, then 2, 2, 1, 2, 3, 4, 28, 28, and then 3. Correct. So you see, if I perform JOR of first part, repetitive number will cancel each other out. We will be left with 15. This is my first unique number. JOR of second part, repetitive number will cancel each other out, and then we will be left with second unique number. So this is how you can solve it. But then clearly there are a lot of hiccups. पहले देखो, जब इसको इम्प्लीमेंट करने जाएंगे तो लेट्स क्विकली इम्प्लीमेंट इट. जैसे जैसे स्टोरी पढ़े ना, वैसे वैसे आपको दिखाते हैं कि इम्प्लीमेंटेशन के वक्त व्हाट शुड बी योर माइंड सेट. जो चीज़ पेन एंड पेपर पे किए, अगर इम्प्लीमेंट करते वक्त उससे थोड़ा सा भी अलग किए तो फिर आपके लिए दिक्कत है. आप जो कर रहे हो, जो करने वाले हो, उसको पहले से ही पेन एंड पेपर पे क्लीन करके रखो. हेलो. हाँ प्रणाम माँ. समाचार तो हमारा एकदम ठीक ठाक हो. हाँ अभी क्लास ले रहा हूँ. बोलें कोई बात नहीं. चलें तो हम कर रही हूँ कल फोन. और सब ठीक ठाक है ना? ठीक है, ठीक तो हम करबो कल फोन. ठीक नहीं? Okay, so let's quickly try to implement it. I will just create another file and then let's name it toUnique. Yeah, toUnique.java, and probably we will take the same array here. So let's have a class to unique, then let's have our main method, and then let's have an array. Okay, and let's take any array. What difference does it make? We don't really need to go with same array. So 7, 12, 24, 38, 38, 37. I think in this array every number is repeating except 37 and 45. Correct? Please look at the data set. Is this correct? The array? Okay. Now I need to find both of the unique number. So I will just assume that let's say my first unique number is x, the second unique number is y. Now x jar y, I can get it like this, whole jar. I will initialize it with 0 and then I will say that for every element that is present in my array, please jar it with this particular variable, whole jar. Okay, whole jar jarred with this element e. And now whatever this value is by this time, so let's quickly check this one out. What is this value? Whole jar. Okay, this is nothing but jar of x and y. I have named it whole jar because effectively it is jar of whole array element also. You can also name this variable jar of unique numbers or anything like that. We will first take it and then we will verify it. So I got 8. In this case, my unique numbers are 37 and 45. 45 and 37. So I will just check what are the binary form of these two values I do not want to evaluate. So I will just write binary of 37 and 45. I am using my phone, okay? So 37 is this 1 0 0 1 0 1 and 45 is 1 0 0 0 1 1 0 1101. This is 45. No, this cannot be true. Is it true? 10 1101 101101 and 37 is 100101. This is correct. If we perform jar of this, see 1 jar 1 0 0 jar 0 0, then again 0. Here we have 1 0 0. So 0 1 2 3. This is very much fine. Okay, this was my x, this was my y. In my output, this is my x or y, which happens to be 8 only. Okay, now you see the next thing is I can go and pick any set bit position from this sequence. In this case we have only one set bit position, but it might happen that we have more than one, so we can pick any one. But from implementation perspective, we will go with first set bit position only. फर्स्ट सेट बिट पोजीशन ओनली. ओके, बिकॉज इट माइट हैपन कि हमारे पास एक्स और वाई में एक ही बिट है. सो नाउ देयर इज अनदर सब प्रॉब्लम दैट यू नीड टू सॉल्व. यू आर गिवन अ नंबर n. इन दिस केस n की वैल्यू हमारे पास 8 है, होल जॉर, इसी n की बात कर रहे हैं. हमको अब इस वेरिएबल से फर्स्ट सेट बिट पोजीशन ढूंढना है. ओके, सो द नेक्स्ट प्रॉब्लम दैट वी आर सॉल्विंग हियर, यू आर गिवन अ वैल्यू n. ओके, फाइंड आउट पोजीशन ऑफ फर्स्ट सेट बिट. एकदम स्ट्रेट फॉरवर्ड पोजीशन है, उसके सॉल्यूशन है, उसके बारे में पहले देख लेते हैं. देखो, व्हेन यू गो एंड राइट इवन नंबर्स लाइक 0 2 4 6 8 10 एंड सो ऑन सो फोर्थ. दिस इज 0, दिस इज 2, दिस इज 4, this is 6, this is 8, then this is 10 and so on so forth. You will realize that even number always have their first bit as 0. Okay, even numbers will always have their first bit as 0. In other case, odd numbers will always have their first bit as 1. This is 1, this is 3, this is 5, this is 7, you keep going forward, this is 9. So odd numbers will always have their first bit as 1. Okay, so this is also another observation that you need to be aware of. Even numbers always have their first bit as 0, odd numbers always have their first bit as 1. Okay, and then apart from this there are two more bitwise operators that we will learn here itself. This is what is this direction? Is this right
Left,
or is this left?
right.
अरे यार बोलो जल्दी. This is right. This is right. Okay, is this correct or not? So this
Yes,
is
sir.
right shift, and then there is another operator left shift. Okay, let's quickly learn about these two operator also. So let me just write it so that I do not get myself confused. And this is my left shift. Okay, see how exactly these operators work is very interesting, and I think all of you must already be knowing. If I do something like this, 8 left shift 2. Okay, so you see what will happen from binary form of 8. So this is my 8. Okay, left shift 2, from left 2 bit will be disposed. Okay, so 8 is not 1000, 8 is first 280 and then 1000. So here 2 leftmost bit is 0. So these 2 bits will be disposed and 20 will be appended at the right. So this number will become this. Okay, do you understand this or not? If I perform 12 left shift 3, so 12 is what? This is 12 left shift 3. Actually we have 280 here, and then we have 1100. So first 2 bit from left will be discarded. Again, it does not matter these bits are 0 or 1, they will be discarded irrespective of 0 or 1. So even if they are 1 0, then also it will be discarded. And then 3 bit, in this case 3 bit will be discarded and 30 at right will be appended. So this is going to give you something like this, 30. Okay, now look at what exactly this number is. 0 1 2 3 4 5, it is 32. So can I say that 8 left shift 2 is nothing but 32, or can I say that 8 left shift 2 is nothing but 8 into 2 raised to power 2? Okay, then here 2 raised to power 2, here 0 1 2 3 4 5 6, 32 plus 0 1 2 3 4 5, 64 plus 32. So what is this? 6 9 96. So can I say that 12 left shift 3 is nothing but 96 is nothing but 12 into what? 2 raised to power 3. So this 3 is actually how many bit you have left shifted. Okay, similarly if someone comes to you and asks you what exactly a left shift b, a left shift b is nothing but a into 2 raised to power b. Do you understand this, every one of you?
Yes, sir.
Okay, and similarly there is right shift, it works. अच्छा, अगर किन्हीं को वो है ना थोड़ा सा तकलीफ हो गया उसमें, तो आप इस पे देखो. If I do 2 left shift 3, so 2 is this, I am trying to left shift it 3 times. So here 0 0 0 and then first we have 30. So first 30 from left will be discarded and 30 at right will be appended. So it is going to give you a binary sequence like this. And of course here we have 27 0. So 0 1 2 3 4, it is nothing but 2 raised to power 4, 16. So can I say it like this, or no, that it is nothing but 2 raised to power 3, 2 into 2 raised to power 3. So a left shift b is nothing but a into 2 raised to power b. That's it. Right shift like this. Okay, it is going to give you something like this, a divided by 2 raised to power b. Let's quickly verify it. For example, if I do a right 10 right shift 2, so 10 is this 8 plus 2 right shift 2. So 2 bit from right will be disposed and 2 0 at left will be appended. So it is going to be this 1 0 and then we have 30 0 on left. Okay. So this number is 2. Now here can I say it like this or not, that it is nothing but this 2 raised to power 2. Okay. 10 divided by 4 is programmatically 2. Okay. We do not care about decimal part. You will be able to divide 10 only 2 times with 4. Okay. So remember these two things. And now let's come back to our original concern that we had. So we are given a number and we need to find out first set bit position from that number. So can I do it like this or not? Think about it. Let's say that my number is 23. Okay, or instead of 23, let's just have a look at some binary sequence. Let's say this is the number that's given to me. Okay, it will not be given to you in binary form, but remember, whenever you use any bitwise operator, whether you use AND, OR, JOR, right shift, left shift, negation, whenever you use these operators internally convert your decimal into binary, operates on that binary, generate a result in binary, then convert that binary into decimal and gives you decimal. So you don't need to convert these numbers into binary and so on and so forth. Not only this, when I will give you this number, I will give you decimal format of this. But essentially, think about it. If someone asks me that find out first set bit position of this sequence, can I write this code like this or not? That see, I will assume that my number is odd. Okay, so I will initialize my answer with 1. Why? Because I have just told you that odd numbers will always have their first bit as 1. So if I give you a odd number, your answer is 1 because first bit is set. Okay, then can I write something like this, that while n mod 2 is 0, then do something, and then after this you return your answer. Now whatever is written inside this while loop, it does not matter for odd numbers. Okay, no matter what you write here for odd numbers, answer will be initialized at 1 and it will return 1. Do you understand this? And it is correct. If I give you a n that is odd, for example, if I give you 17, this logic will return me 1. That is correct because 17 has its first bit as 1. 0, 1, 2, 3, 4. Okay. So for 17, my first bit is present at position 1. If I feed you another odd number like 5, so for 5 also we have first bit as 1. So this logic, it is going to run only when my number is even. You see, n mod 2 double equals to 0. 17 mod 2 is 1. 5 mod 2 is 1. It is not 0. So for odd numbers, this loop will not execute. So whatever you wrote inside, it will not matter. Do you understand this? Okay. Now think about even numbers. You see what I will do in case of even number. For example, you take this sequence itself. I will keep on right shifting my n by 1 bit. And every time I right shift, I will move my answer by 1. Now see, for this number, let's say that I feed you n equals to 1. This is clearly a odd number. I don't know what, even number. I don't know what the number is, but it is clearly a even number because my first bit is 0. So even numbers always have their first bit as 0. Odd numbers always have their first bit as 1. Okay, since this first bit is 0, I know that this number is even. So control will come inside. I will right shift n by 1 bit. So 1 bit from right will go away and 1 0 at left will be appended. Now this is the number we are left with. And my answer will change to 2. So initially my answer was 1. From 1 it will change to 2. Then again, is my number still even? Yes, it is still even. This is your first bit now. This is still 0. So this loop will execute one more time. I will right shift it by 1 time. So this 0 will go and 1 0 at the left will be appended, and from 2 my answer will become 3. Now, is this number a even number? No. Now you see this number become an odd number because now my first bit is 1. So this loop will terminate and I will return answer. By this time my answer is 3. And you see, in my original sequence, third bit was first set bit. Do you see this or not? So this logic that you see here, it will give you first set bit position of any n, provided n cannot be 0. If your n value is 0, then this loop will fall in infinite loop. Okay, so because for n we do not have any set bit. Do you understand this, every one of you, how you can fetch first set bit position? Is there anyone who is having any doubt? Please feel free to ask. This is the right time to ask. Okay, so if no doubt, then let's move forward with the implementation. You see here, once I have evaluated whole jar, now I want to know first set bit position from this jar. So can I do something like this, that pos is nothing but get first set bit pos, and then I will pass it the value for which I want to get the first set bit position. And how we will be implementing this particular method, that I have just explained to you. And while explaining this, we have also learned about left shift and right shift. Let's quickly implement this. So get first set bit position, it will take a number n. So what I will do, I am going to initialize a variable answer with 1, and then I will say that as long as my n mod 2 is 0, okay, you keep on right shifting n by 1 bit. Every time you right shift, you also move your answer, and then once you are done with this, you just return your answer. Okay, now this method is going to give me first set bit position. Okay, once I got first set bit position, why is this producing error? Okay, so you see, this is a common Java error. A non-static resource cannot be referenced from a static context. Your main method is a static. This method is not a static, so you cannot call it here. One simple solution, remove this static keyword from here. But if you do this, JVM will complain. So another solution, you make this method also a static. Okay, these are Java related terminology, we will not focus on it for now. Okay, this will also solve the problem. Now we got first set bit position. Now let's say that this pos value is something like 4. Okay, so from whole jar, I have performed jar of whole array, I got x jar by. This is just stored in whole jar. Then from this method, I have brought first set bit position. Now let's say that first set bit position is 4. Now for every number, I want to know that if this number has 1 or if it has 0 here at 4th position. So this is also very simple. For example, if I give you this sequence and I ask you that tell me the bit value at position 3. So I am talking about this. So you see what I will do, I will right shift this number 2 times. So this 2 bit will be gone, and then I will check that if this number is even or odd. If this number is odd, then this bit value is 1, otherwise this bit value is 0. For example, from this sequence, if I ask you, let's say 5th bit, tell me what is the 5th bit. So I will first right shift this number by 4 times. So this 4 bit will be gone, and now if this number is even, then my 5th bit is 0, otherwise my 5th bit is 1. Do you understand this, guys? Okay,
Yes, sir.
so we can write one more method here, public static get ith bit. Okay, so it is going to take a number n and it is going to take a bit position. So if I wish to know ith bit of this n, you see what I can do. First I will right shift this n I minus 1 time, and actually you need to right shift it like this because jar operator has higher precedence here. So if I write it like this now, it will not work. The reason being, it will first perform right shift on I, and then whatever this output is, it will subtract 1. But I want to right shift it I minus 1 time, so I have just enclosed everything inside a bracket, and then I will return n mod 2 if my last bit is 0. If my number is even, it means that my ith bit is 0. Correct? So n mod 2 will return 0 for even number. if my ith bit is 1, it means that this number is now negative. N mod 2 will return 1. Does it make sense? Implementation of first set bit position and ith bit. Does it make sense to everyone? Or is it too much? Is it going above your head? Please feel free to mention. Is there anyone who is having any doubt, any concern? अगर डाउट नहीं है ना तो वो भी
Yes,
बोलना
sir.
होता है. नो डाउट.
Yes, sir. Doubt है.
नो डाउट.
Doubt है. Sir,
बोलो.
doubt है.
पूछिए.
सर ये 19 में.
लाइन नंबर
19 से लेकर जो नीचे पहुंच रहा है तो सब जो हम लोग बना रहे हैं. Get the bit वाला. हाँ उसमें.
इसको देखिए, फिर से देखते हैं. मान लो कि मैंने आपको एक नंबर दिया, ठीक है यन, और मैं आपसे पूछ रहा हूँ कि भैया इसमें हमको ith बिट बताओ. फॉर एग्जांपल लेट्स से दिस नंबर इज 23 एंड i वैल्यू इज 3, एनीथिंग. सो 23 इज 18 plus 4 plus 1. 18 is 16 plus 2, so 16, 8, 4, 2, 1. This is 23, I guess. 0, 1, 2, 3, 4. 16 plus 0, 1, 2, 4, 20. This is 23. And let's say I value is 3. So I am asking you that tell me what is the third bit in this particular number. So you see, in order to check the third bit, what I will do, this sequence, first I will right shift it 2 times, I minus 1 time. So when I right shift it 2 times, these 2 bit from right will be gone and I will be left with this. This number is 5. So if this number is odd, it means that this bit is 1 and it is the same bit that was asked to you in your original sequence. Correct? So can I not return something like this, n mod 2, because or you can also write something like this, that if n mod 2 is 1, it simply means that number is odd, return 1, else return 0. Okay, or let's look at some of more test cases. Let's say that I give you a sequence like this. I will not give you this binary sequence, I will give you its decimal value, and I ask you that tell me what is the 7th bit in this particular number. So I am talking about 1, 2, 3, 4, 5, 6, 7, this bit. So first thing that I will do, this sequence I will right shift it I minus 1 time, 6 times. So 1, 2, 3, 4, 5, 6. These 6 bit from right will be gone and I will be left with a sequence like this. Okay, now I want to look at this bit. This bit is the same bit that is now first bit in this number. So I have updated my n like this. Okay, I have updated my n like this. So the 7th bit in my original sequence is now first bit in this number. Correct? And if this number is odd, it simply means my first bit is 1. If this number is even, it simply means my first bit is 0. So I can return this or not. अगर odd होता तो n mod 2 की वैल्यू 1 होती, और odd है तो मेरा पहला बिट 1 ही है. अगर इवन होता तो n mod 2 की वैल्यू 0 है. अगर इवन होता तो मेरा पहला बिट 0 होता. समझे किशन?
Yes, sir.
Okay, so the same thing I did here. हमसे पूछा जा रहा है इस नंबर में ith बिट बताओ, तो पहले हमने इसको i minus 1 टाइम राइट शिफ्ट कर दिया, फिर हम n mod 2 रिटर्न कर रहे हैं. अगर नंबर अभी भी ऑड है तो 1 रिटर्न कर दो, अगर नंबर इवन है तो 0 रिटर्न कर दो. Is there anyone else who is having any doubt in these two implementation? Get first set bit pos, get ith bit. Please feel free to ask for help. I will repeat it one more time if you ask, but then you need to ask for it. Anyone? Okay, now let's come back to our original implementation to find both unique number. जोड़ कर लिया होल एरे का, उस जोड़ से पहला सेट बिट पोजीशन भी निकाल लिया. अब हमको हर एक एलिमेंट के लिए जानना है कि उस एलिमेंट में हमारा पहला बिट 1 है या 0. सो हम एक एक करके सारे एलिमेंट के पास जाएंगे. पहला बिट नहीं, ये वाला बिट पोजीशन, एक एक करके सारे एलिमेंट में जाएंगे और हम पूछेंगे कि बताओ इस एलिमेंट में ये वाला पोजीशन 1 है या 0 है. अगर ये 1 है तो हम कुछ और करेंगे, अगर ये 0 है तो कुछ और करेंगे। तो यहाँ पे ऐसे करके रख देंगे। करेक्ट। अगर ये वाली वैल्यू 1 है तो कुछ करेंगे क्या, उसको अनदर एरे में पुश कर देंगे। समझ गए? लाइक कि हम यहाँ पे 2 एरे लेके चल सकते हैं, ARR1 और ARR2। सो अगर ये वाली पोजीशन 1 हुई तो उसको ARR1 में रख देंगे, अगर ये वाली पोजीशन 0 हुई तो ARR2 में रख देंगे। तो हम वही कर रहे हैं, पहले हमने एरे का जॉर कर लिया, फिर हमने उस जॉर रिजल्ट से पहली सेट बिट पोजीशन निकाली। अब हर एक एलिमेंट को उस पोजीशन के आधार पे अलग अलग एरे में रख रहे हैं। करेक्ट। अगर इस एलिमेंट में ये वाली पोजीशन वैल्यू 0 है तो उसको एरे 1 में एरे 2 में रख देंगे, या एरे 1 में रख देंगे, नहीं तो एरे 2 में रख देंगे। रख के करेंगे क्या, जोड़ करेंगे लास्ट में। तो आप रखो फिर जोड़ करो, उससे अच्छा है कि आप यही पे जोड़ करते जाओ। तो मैं 2 आंसर मेंटेन करके चलूंगा, आंसर 1 आंसर 2 दोनों 0 रहेगा। जब भी कोई वैल्यू पहले सेगमेंट में जाने वाली होगी तो हम उसको रखने स्टोर करके बाद में जोड़ करने के बजाय यहीं पे जोड़ कर देंगे। स्टोर करके जोड़ नहीं करेंगे, रनिंग टाइम में जोड़ करते जाएंगे। अगर कोई वैल्यू सेगमेंट 2 में जाने वाली होगी तो उसको आंसर 2 में जोड़ करते जाएंगे। डज इट मेक सेंस टू एवरी वन ऑफ यू? देखो हम एक बार फिर से आपको सब कुछ एक्सप्लेन करते हैं। हमारे पास सिचुएशन ये है, एक एरे दी हुई है, आपसे बोला गया है कि इस एरे में एवरी नंबर इज रिपीटिंग एक्सेप्ट एनी 2 नंबर, फाइंड मी दोज नंबर। तो हमने बोला कि भाई देखो मेरे को दो इक्वेशन चाहिए। एक इक्वेशन तो हमको यहां से मिल जाएगा, करेक्ट, जॉर ऑफ होल एरे। इसी को हमने नाम दे दिया है इस प्रोग्राम में होल जॉर, करेक्ट, होल जॉर। वो हमने कर लिया, सारे एरे एलिमेंट का जॉर करके होल जॉर निकाल दिया, ठीक है। फिर उसके बाद हमको इस वैल्यू से पहली सेट बिट पोजीशन चाहिए, तो वो हमने इस मेथड से पूछ लिया, गेट फर्स्ट सेट बिट पोजीशन। मान लो इस मेथड ने आपको रिटर्न किया 3, तो अब हमको हर एक एलिमेंट के लिए चेक करना है ना कि उसका थर्ड बिट 1 है या 0 है। अगर थर्ड बिट 1 है तो उसको एक सेगमेंट में रखेंगे, अगर थर्ड बिट 0 है तो हम उसको दूसरे सेगमेंट में रखेंगे। बाद में रख के क्या करेंगे, सबका जोड़ करेंगे, करेक्ट। तो रखो बाद में जोड़ करो, उससे अच्छा है कि रनिंग टाइम में ही जोड़ करते जाओ। अगर इस ई को पहले सेगमेंट में जाना था तो उसको आंसर 1 में जोड़ कर देंगे, अगर दूसरे सेगमेंट में जाना था तो आंसर 2 में जोड़ कर देंगे। सो पहले रख लिए, बाद में ऐसे जोड़ करके आंसर 1 निकाला, फिर रख लिए, बाद में जोड़ करके आंसर 2 निकाला। उससे अच्छा है कि जब आपने डिसाइड कर लिया कि इसको इधर जाना था तो उस वक्त स्टोर न करने के बजाय अब डायरेक्ट जोड़ करते हैं। चलो समझ में आई इंप्लीमेंटेशन सबको? Guys, is it too much? Then please ask for help, and then at the very end all we will have to do is we will have to print this answer 1 and answer 2. Okay, so let's quickly have a look if it is working or not. We will remove our extra CISO. In this case we should get our both of unique number. I do not remember what those unique number was. $45 and $36, करेक्ट। सो डू यू अंडरस्टैंड दिस इम्प्लीमेंटेशन? नाउ देखो इस प्रॉब्लम को लेके हमने कुछ मल्टीपल सब प्रॉब्लम्स भी सॉल्व करे, जैसे कि गेट फर्स्ट सेट बिट पोजीशन, गेट ith bit, then we have also learned about right shift and left shift operator. If someone comes to you and they ask you what is this value, so it is nothing but a divided by 2 raised to power b. What is this value? It is a into 2 raised to power b. या मैं उल्टा बोल रहा हूँ, अभी हमने वो करा था ना, इसको डिराइव करा था ना, शायद हमने हटा दिया। ये करेक्ट है ना? और हैव आई रोट इट अदरवाइज?
Yes, sir.
करेक्ट।
Yes, sir. Correct.
तो लेफ्ट शिफ्ट राइट शिफ्ट भी पढ़ा, गेट फर्स्ट सेट बिट, गेट ith bit, एंड देन वी हैव ऑल्सो इम्प्लीमेंटेड दिस 2 यूनिक नंबर प्रॉब्लम, करेक्ट। किसी को भी इम्प्लीमेंटेशन में थोड़ी सी भी डाउट है, इफ यू वांट मी टू रन इट ऑन अनदर टेस्ट केस, प्लीज फील फ्री टू आस्क फॉर हेल्प। एनीवन? गुड। Now we are done for today. Before we move forward, I will give you one problem to solve to practice at your home. प्रोडक्ट एक्सेप्ट सेल्फ, इसका एक्चुअली जॉर से कोई लेना देना नहीं है, प्रीफिक्स सफिक्स अप्रोच से कोई लेना देना नहीं है। मैंने लास्ट क्लास में मिस्टेकनली आपको प्रोबेबली ये बोल दिया था कि प्रोडक्ट एक्सेप्ट सेल्फ इसको भी जॉर से ही करेंगे, बट देन दैट वाज अनदर प्रॉब्लम. This is a problem that we will discuss tomorrow. You will be given two numbers A and B, and then you need to find out A divided by B without using this operator. Okay, it makes things very interesting, and then there is a very beautiful learning curve when you go and try to solve it using JOR. So we will continue our discussion on bit manipulation a lot, like 1-2 more days, 3-4 more days maybe. For now I will just leave you with a problem. Product except self. Problem statement is very easy. You are given an array. Let's say this is the array that we are talking about. You need to prepare another array answer where answer of 5 will represent product of whole array except index I. So here I will have 8, then here I will have 6, then here I will have 24, then here I will have 12. Okay, and one constraint on this problem is you cannot use division operator. So you cannot do it like this, that first we have a stored whole product inside a variable like whole product, and then we went to every element and kept on dividing. Okay, you cannot do that. You cannot use this division operator. Use prefix suffix approach. थोड़ा सा दिमाग लगाइए, आपको समझ में आ जाएगा कि कैसे कर सकते हैं इसको. This goes your homework. Okay, now apart from this I will send you this code so that you can debug into it on your own. और इसको ऐसे ही मत छोड़ दीजिएगा, आज रात को ही चीज़ों को खुद के लिए एक्सप्लेन कर लीजिए. लाइक कि जैसे जैसे हमने आपको स्टोरी बताई है ना कि फर्स्ट वी विल जॉर होल एरे, then from that jor we will find first set bit position, then we will take that position and we will go to every element and we will check if that position is 1 or 0 in that element, and accordingly I will put that element either in segment 1 or in segment 2. So you can put and jor later. I didn't do it because it will require knowledge of array list, और एरे लिस्ट हम लोगों ने अभी डिस्कस नहीं किया. हमको पता नहीं कि पहले सेगमेंट में कितने एलिमेंट जाएंगे. ऐसा भी हो सकता है कि एक को छोड़ के सारे पहले में ही चले गए, तो डायनेमिक एरे का कॉन्सेप्ट आ गया यहाँ पे. बट देन इट डज नॉट मेक एनी डिफरेंस बिकॉज हमको बात रख के उसको बाद में जॉर ही करना था. तो जब जॉर ही करना था तो रख के जॉर करने से अच्छा है कि अभी ही जॉर करते चलो. सो दैट्स हाउ वी डिड इट. ओके, I will give you the code